Hey guys, welcome back. So in this lecture, I'm going to talk about the Moivre's theorem. Okay, now the Moivre's theorem is used when a complex number that is expressed in its polar form, and that polar form is raised to a power. Okay, so let's do an example. So for example, if z is equals to r1 cis theta 1, then if I say, okay, what is z to the power of say 3? Okay, now if I raise everything by 3 here, that means it is r1 to the power of 3 cis 3 times of that angle, which in other case the general formula for de Moivre's theorem is z raised to the power of n is equals to rn cis n theta. Okay, so what is this useful? It is very useful if you have, say, for example, say 3 plus 4i raised to the power of, say, for example, 5. Yeah. Now you can do that 5 times, and that's going to take you a very long time. What you can do is that you can first convert that into a polar form, and then you use de Moivre's theorem to find the polar form that is raised to the power of 5, and then you convert that back to the rectangular form. Okay, so it's that simple. So let's do that example. 3 plus 4i raised to the 5. Okay, now I'll just do it here. So whenever we need to convert a complex number into a polar form, we first need to draw out the we need to draw the complex number on the Argand diagram, right? So here's my Argand diagram, where this is the real axis, this is the imaginary axis. Okay, so let's say this is my 3, that is my 4. So this is where my complex number is lying. Okay, so this is my z. Okay, this is my z. Now, which angle do I need to calculate? Well, I need to calculate this angle. Yeah, so this angle theta, and the modulus would be from this distance to this distance. So z is equals to, or modulus of z is equals to 3 square plus 4 square, and then everything square rooted. So that will be equals to 5. Okay, now what about the argument? The argument of z, well, if you look here, that is just like a normal right angle triangle, right? So that's that. Well, this is right angle, this is 4, this is 3, this is my theta that I need to calculate. So actually that will become 10th inverse of 4 divided by 3. Okay, so that would be 0.927 radians. Right? Now, if we put everything together, then therefore my polar form is equals to, that will be z equals to 5 cis 0.927 raised to the power of 5. Okay, so now in this case you need to use the de Moivre's theorem to get that. Okay, so that will be 5 raised to the 5 cis 0.927 times 5. Okay, so that would be oh, I forgot the 5 here, raised to the power of 5. Okay, so that would be 3125 cis of 4.635. Okay, so that's the polar form that is raised to the power of 5. Okay, now if we need to put it back into the rectangular form, that would just be 3125 of cos 4.635 plus I sine 4.635. Okay, so that would be negative 2 for 1.0.60 minus 3115.6 4.65i. Okay, hope that's clear. So just to recap, de Moivre's theorem is used when a complex number that is in its polar form raised to a power. Okay, so here's the general formula for de Moivre's theorem. Okay, so it's this one here, and then it is used for when you have a rectangular form complex number that is raised to a high value. So for example 5 or 6 or 7. Okay, now the first thing you need to do is that you need to convert rectangular form complex number, which is this 3 plus 4i, and then you have to find what is the polar form for that. Okay, now whenever we need to sort out the polar form stuff, you always need to draw that on the Argand diagram first. Okay, don't forget, it is very important. So this is the Argand diagram. Okay, so I need to find this angle theta, or I can find this angle, but that will be a negative angle. Okay, now for convenience I only need to calculate this angle. Yeah, so just like any other triangle, if this is my theta that I need to calculate, then tan inverse of 4 over 3, that will give me my angle. Okay, now the modulus will be the Pythagorean theorem. Okay, so that's 3 squared plus 4 squared gives me my radius. Okay, so if we put everything together back inside the bracket, this is my polar form, and it's raised to the power of 5. So from here I need to use the de Moivre's theorem. Okay, de Moivre's theorem. So you solve that, and then that's your final solution. Okay, now if you need to convert that back into the polar form, the rectangular form, this is what you need to do. You need to re-expand the cis. Remember, so cis theta is equals to cos theta plus I sine theta. Okay, so expand this, and then put the radius back in. Okay, and then that's your answer in the rectangular form. Okay, so I hope that makes sense, and if it doesn't, please feel free to leave me a message on the discussion board, and I'll get back to you as soon as possible.